Now I just have one concern about this code. It's starting to look a little bit messy. To do this operation I've needed, if we ignore the setting up at the top, from this point here I've needed I'd say about 10 lines of code to do the operation. Now I can tell you that a Scala developer or a Python developer using Spark would be laughing at us now, and they'd be saying, oh, look at how horribly verbose Java is. As I said in the introduction chapter, as long as we're using Java 8 lambdas, in general, the code in Java can look very similar to the code in Scala or in Python. But I have sort of allowed myself to get quite verbose here, and I think the only reason for that is because we're learning, because I'm taking things slowly, I'm doing things line by line, and I don't want to jump too far ahead. And I reckon what we can do now is we can very easily refactor this code so that we get all of this really down to a single line of executable Java code. Now the reason for that is all of these methods that we call on an RDD are fluent. And I'm guessing you've probably come across Fluent APIs before. It's a fancy word that just means given any of these operations, the end result of the operation will be it will return an instance of the RDD that you're working on as the return value, which, to put another way, means we can always, once we've done something, we can hit the dot and we will find all of the functions that we need. So we don't really store the result of this in an intermediate variable called original log messages. I could have gone straight to dot map to pair. And then I could do the map to pair here, and then I can call the reduce by key, and then I can call the for each, and I can do that all in a single line of code. So that's what I'm going to do. Actually, before I even do that, I can see another optimization that we could do here, because if you have a look at this lambda function here, which is spanning several lines, well, it was only spanning several lines because I wanted to split out the log level and the date and time. But we've seen now the date and time was never needed. We only needed a 1 in the tuple. So I think we could collapse all of this down into a much shorter line of code. Let's see how that would look. Let's take all of that away. So given the raw value here, we need to return a new tuple 2, and as usual I'll use the angle brackets so it can infer the types. And again, the first value here is going to be split from the raw value, and we're splitting on the colon. That's going to return us an array representing these fields, but we only need the first element from that array, so I can address the first element there using the square bracket notation. And then for the second element of this tuple, well, that's just going to be a 1 expressed as a long. And I reckon that's enough. As long as I've got my brackets sorted out, there'll be 2 round brackets at the end of there, and that's exactly what we had before, expressed as a single line. So already this is looking a little bit neater. So that improvement's good, and now, as I say, we don't need to have our operations spread across 3 separate lines of Java, but in fact 4 separate lines of Java, with all of these intermediate RDDs being created along the way. Instead, we could have done it all as one line of code, and I'm going to make it line 32 here. Now, I don't know yet what the return type's going to be on the left-hand side, so I'll remove the left-hand side. And all I'm suggesting is that once we've done the parallelize, we can then go on and call the map to pair, passing in the function, which I'll copy from here. Okay, so I can now delete line 34. The next operation is to call reduce by key. Now I can see that I'm getting quite close to the end of the line here, so it's common when you're doing these Fluent method calls to separate the line so that the dots are all underneath each other. Now it's still going to be sort of a single line of Java code, it's just that we're splitting it with carriage returns just to make it more readable. So I can then do my reduce by key, And I'll borrow the function from here. That will go in there. And then here's the big deal. I can finish off with my for each. And I'll copy what I have in there. So now I don't need this line 38, and I don't need this line 38. So the code I now have here is identical, in operation at least, to the code that I had before. And as usual, it depends on the way you think. You might have actually preferred the original version. I think I prefer the original version when I'm working an idea up and I'm still debugging and I'm still trying to get my structures into the right format. And then I like to do this cleaning up. I think I prefer this as the final version. Some people would argue this is harder to maintain because you don't have those intermediate RDDs that are going to have like meaningful names attached to them. It's entirely up to you. It's entirely up to your coding standards as to which version you prefer. Because Spark comes from a Scala background, what you see here is very idiomatic to Scala. It's the normal way of working there. So, you know, we don't have to copy Scala programmers, but you might want to bear it in mind that because of this, really, it's a Spark idiom that we will often use, this Fluent API. Anyway, I've gone on about that too much. It looks like I've got now some imports that are no longer needed, so I'll do a Command or Control-Shift-O to clean those up. And let's run again just to check that we haven't broken anything along the way. And yes, that's looking good.